So this is problem 110 from chapter 14. It's one of those problems in brackets which indicates that it's supposed to be challenging, but I think this one's kind of straightforward. Part A, we're looking for the overall reaction, so we need to add up steps 1, 2, and 3. You can see that I've crossed out the intermediates, and hopefully what's left gives us the overall reaction. We don't have anything to compare it to, so we're assuming that what we get here is going to be accurate to describe this reaction. And so we have step 1 is a fast step in equilibrium, step 2 is a slow step. There I'm highlighting the intermediates in blue. We've got two different intermediates, chlorine atoms and carbon trichloride. Part C, what is the molecularity of each of the elementary reactions? So step 1 only involves chlorine gas, so that's unimolecular. Step 2 involves two molecules, so that's bimolecular, as is step 3. Part D asks, what is the rate determining step? Well, the slow step is always the rate determining step. And so you're told in this problem what's fast, what's slow, and so that is a pretty easy determination on your part. So now we're looking for the rate law as proposed by the mechanism. So we've got to examine that slow step. And as we look at that slow step, we find that we have an intermediate in the rate law, and that's not allowed. So we have to back up to step 1, which is in equilibrium, and substitute in for the concentration of the chlorine atom there. So knowing that equilibrium means the forward and reverse rates are equal, we can have a rate law expression for the forward reaction and a rate law expression for the reverse reaction, and then we can solve those, manipulate those and solve for the concentration of chlorine atoms. So we do that and we find we get a new constant, which Kf over Kr is just going to give us a new constant. Whatever that value is, doesn't matter. We're going to take the square root of that. Then we're going to take the square root of the Cl2 concentration, and we find that the concentration of chlorine atoms is some constant times Cl2 to the 1/2 power. Right? That's converting the square root to the exponent form and then adding that new constant in. We're going to do some algebra. We're going to substitute that value then, K prime times chlorine gas to the 1/2 power. We're going to substitute that into the equation. And again, a constant times a constant. We're going to get a new constant, which should be the constant for this rate constant for this reaction. And there we have the rate law in the upper right-hand corner there. Hope this was helpful.